Hi, it's Mrs. Morant once again, here to finish your review. So Unit 3, Part 1, we learned about the connection between exponents and roots. So we worked with exponents that were positive and negative and fractions. And so fraction exponents gave us those roots and negative exponents gave us fractions. So to straighten that all up, so our first one, select all expressions equivalent to 4 to the 5 halves. So I know in this situation, there's this relationship between a base that has a positive fraction exponent and then the way that you write it in root form using a radical. So this number at the bottom, that number is the type of root or the index. And this number on the top is going to be the exponent. And then this is, we just call it the base, and it goes under the radical, okay? So when we rearrange this in radical form, it's the nth root of the base to the m, whatever that number was on the top of the fraction. You can write it in that way, or you can write it as with the exponent on the outside, so the nth root of b to the m. Okay, so either representation, they're totally equivalent. All right, so when we look at this 4 to the 5 halves, I know the 2 is the index of the root, which we never see actually written. It's just a square root. So it's the square root of 4 to the 5th. So that looks like this, the square root of 4 to the 5th. So it can look like this, or with the 5 on the outside of parentheses. So here we go here, the square root of 4 to the 5th. Now, there's one more expression in this particular problem that's also equivalent, because the square root of 4, that's like a known math fact. The square root of 4 is 2. So notice option C says 2 to the 5th. So that's the third one. This has the wrong index. This has the wrong index. They're in the wrong spot, okay? And so A, C, and D are the 3 solutions for number 17. And then for number 18, this time we have a fraction. So when you have a fraction, this relationship with the root still apply, but because of the fraction, I know the exponent's going to be negative. So we learned that, let's see, I can write it, I'll write it with the fraction representation coming first. Okay, so we learned that, oh, I should have kept that in a root, sorry. We'll just forget about that for a minute. So I'll say 1 over the nth root of b to the m, just so I'm keeping it in the same form of how this problem is starting. All right, so I can first keep this as a fraction and write the root part as b to the m over n. And then if I want to just bring this up, all I do is make the exponent negative. Okay, so if you think about, how does that apply? Can you see representations like this down in the answers? All right, so this is the cubed root of 2. The cubed root of 2 equals 2 to the 1/3. Okay, so let's keep that in mind. So it doesn't equal 2 to the 3rd. So this is not going to be an option. 1 over 2 to the 3rd is not the same as 1 over the cubed root of 2. However, 1 over 2 to the 1/3 is the same because of this relationship, right? So the cubed root of 2 is just being rewritten as 2 to the 1/3. So this is a correct answer option. C, that's just kind of there as a distractor. If you thought this was correct, then that would be correct, but neither one is, okay? And then 2 to the negative 1/3. So it's kind of like, here's where we start with this problem, here's the middle, and then here's like the final result. So here's where we start, here's the middle, and then the final result would look like that, because to move 2 to the 1/3 out of the fraction, you just make the exponent negative. So those would be equivalent also to that. And then 2 to the negative 3, not the same, because we were looking at a cubed root. So just B and D for number 18. So once again, I hope that was helpful, and that concludes the review for the final.